Hi everyone. I hope you all are doing good. So in my today's session, I'm going to cover the mediator design pattern. So let's start with it. So according to the Gang of Four, what is mediator design pattern? Okay, so the Gang of Four says that define an object that encapsulates how a set of objects interact with each other. Mediator promotes loose coupling by keeping objects from referring to each other explicitly, okay, and it let us vary their interaction independently. Okay, so what it says is basically in order to achieve interaction or communication between n number of objects, okay, each object holding object reference of other object is not a good practice or not a good idea basically. Okay, it basically couple your objects with each other. Okay, so what they say is in order to avoid that, define an object which is called a mediator that encapsulates how a set of objects interact with each other. Okay, mediator promotes loose coupling by keeping objects from referring to each other explicitly, as I already explained, and it let us vary their interaction independently. So with the use of this pattern, basically we can change or enhance the way they interact basically independently from the set of objects, guys. Okay, so that is the use of most important use of mediator design pattern, I would say. In object-oriented programming, programs often consist of many classes. Business logic and computation are distributed among these classes. However, as more classes are added to a program, especially during maintenance or refactoring, the problem of communication between these classes may become more complex. Okay, and it is very difficult to debug also. This makes the program harder to read and maintain. Furthermore, it can become difficult to change the program since any change may affect code in several other classes, hence causing a lot of regression. Okay, so in order to avoid such things, we need to make use of this pattern. Okay, so for this pattern, I would like to take an example of air traffic controller, okay, which is found in our airports. So what is this air traffic controller? This air traffic controller basically acts as a mediator. Okay, so for example, suppose there is a flight 101 which is returning from Germany, okay, and it wants to land on runway 01. Okay, so what this flight does, the pilot doesn't directly initiate a interaction or communicate with other flight pilots basically. Okay, that is not allowed. So what he or she does is they basically send a request to the ATC that, boss, I want to land on runway 01. Am I allowed to do that or not? So this ATC will check the availability of the runway in that airport. If it is available, then what it does, it basically sends a signal to the flight that yes, you can land on runway 01. And apart from doing that, what this ATC does is it also informs other flights which are about to arrive and tell them that flight 101 is going to use runway 01 to land, so you people do not use that runway to land, request for some other runways basically. Okay, so if that runway is not available, okay, suppose if it requests for a runway 01 and if that runway is not available, then this ATC will tell the flight to pick some other runway, and if it picks that runway, then that same information will be conveyed to all other flights. So basically the communication and coordination is done by this ATC, or I would say the mediator object over here, guys. Okay, no flights will directly communicate with each other. Okay, so that's a simple example to understand the mediator design pattern basically. So what problems mediator design pattern can solve? Tight coupling between a set of interacting objects should be avoided. Yes, tight coupling between a set of objects like one flight directly communicating to other flight pilot, it should be avoided. Okay, it should be possible to change the interaction between a set of object independently. Yes, we should have a possibility to change the interaction, okay, in such a way that the way how flight 101 communicates with ATC is different from the way flight 107 communicates with the ATC. Okay, that's why they say it should be possible to change the interaction between a set of objects independently. Okay, the interaction of this flight should not depend on this one. Okay, tightly coupled objects are hard to implement, change, test, and reuse. That's for sure, because it's very difficult. Making change in one place will break other places. Okay, break the application in other places, and also it's very difficult to debug. Okay, and as they already explained, hard to implement. It's very hard to change. It's very hard to unit test, and most important thing, you can't reuse it because all the objects or the objects refer to, and they know about what all different objects are being used by them. Okay, because one object knows to whom it refers. Okay, and also it is hard coded in such a way that it is very difficult to reuse that communication mechanism, guys. Okay, so that's what they say. Tightly coupled objects are hard to implement, change, test, and reuse because they refer to and they know about many different objects. So what solutions mediated design pattern provide? Define a separate object which is called mediator that encapsulates the interaction between a set of objects. Okay, instead of one object referencing other object directly to achieve this interaction, what solution this pattern provides is you define a separate object which is called mediator, and that particular object encapsulates the interaction between a set of objects. How it is going to happen, I'm going to show you with a code example. Okay, so objects delegate their interaction to a mediator object instead of interacting with each other directly, as I already explained. The objects interact with each other indirectly through a mediator object that controls and coordinates the interaction, because it's completely the responsibility of mediator to control and coordinate the interactions. This makes the objects loosely coupled. They only refer to and know about their mediator object and have no explicit knowledge of each other. Yes, the moment mediator takes the charge, because this is the object which controls and coordinates the interaction now. Okay, this makes the objects completely loosely coupled. They are not referring to each other directly. No object references in the class. Okay, they only refer to know about their mediator object. That's it. Rest mediator will take care, guys. Okay, and that's why they have no explicit knowledge of other objects in the communication. The UML class diagram, very simple. Abstract base class or a contract or an interface you would specify for a mediator. Okay, and then you specify your interaction mechanism or the methods, basically you would say, I would say. Okay, and then a colleague object basically, or a colleague abstract base class. Okay, which is basically the participant or a set of objects or object which is going to interact with other objects. So those in order to represent those set of objects, we have to specify it as a colleague. So those objects are called colleagues basically. So that's why you should have an colleague class or a abstract base class. Okay, and this colleague object or class should hold or maintain a reference to your mediator. As I already said, all the control and coordination and interaction will be taken care by the mediator only. Okay, so that's why all the colleagues or participants should maintain a reference to the mediator object. Okay, then you provide the concrete implementation for your mediator, like concrete mediator. So I'm going to take an example for my code example, which is called MS Teams group chat. So I will create a Teams group mediator basically, and then I will be having the concrete colleagues. So my colleagues are basically who? The team members or the company employees. Okay, so they will basically inherit from colleague, and there I will provide the further implementation which I'm going to show you through the code. Okay, and this concrete mediator maintains the list of colleagues which are going to participate in the interaction. Okay, that's why this notation over here. Okay, so well, that's all about the UML diagram. Okay, so let's jump into the demo now. So let's start with the first thing. Okay, so uh, first thing, I should specify, as I already shown in the UML diagram, I should have a contract for mediator, which I have over here, which is called public interface I group mediator. So I'm taking an example of MS Teams group chat. So I have a method send in order to send a message into group chat, and then add colleagues or add employees to the group chat. So send basically receives a message as well as the colleague or the team member who is sending the message. Okay, and then add colleague, this basically accepts a colleague or the user basically for that group chat. Then I will go to the concrete implementation of Teams Group Mediator. But before that, let me show you how the colleague will look like. So let's go to the colleague abstract base class. So I have given a name in order to show the name of the employee or the user who is involved in the group chat for sending and receiving messages. And then the most important thing, as per the UML diagram, the colleague should hold an object reference to your mediator. Okay, so this is achieved through composition. So colleague basically contains a pointer or object reference to your mediator object, or it basically contains the mediator object in the class itself. So that's why I have specified public I group mediator over here. Then I will set the colleague name through the public constructor, and then I will provide two abstract methods to send and receive the messages. Okay, so why these are abstract in nature? See, take an example over here. The way how a air traffic controller as well as the flights send and receive the message is very different from your MS Teams group chat where you send and receive the message. Okay, that's why they are abstract in nature. And when you provide a concrete implementation to this colleague, you implement those methods as per your need or the context basically. Okay, so I covered these two parts over here now, the public interface, okay, the contract for mediator and the abstract class for the colleague. That is done. Now let's go to the concrete implementations. So first one is the Teams colleague, which basically inherits from the colleague. Okay, same, you are calling the base constructor of the abstract base class to set the name. Okay, and then you have overridden the methods to send and receive the messages. Very simple thing, very trivial example, guys. In the receive, whatever message I receive, I'm putting the name of the colleague, okay, which is coming from the base class. Okay, I'll put a received tag and then whatever message I received. And then when I send the message, very important part, okay, I receive the message, okay, then what I'm doing, instead of directly sending to another object, see, I'm making use of mediator. Okay, and how this mediator is coming? It is basically in your base class, as I already explained. Okay, the mediator should be a object reference, or it should be part of your colleagues class. Okay, so through composition, I have basically put a object reference variable over here in order to point over mediator object. Okay, so that's what I was explaining. Yeah, I was in the send method. So when I send, instead of directly sending to other object, I make use of the mediator, and then I will call the mediator send a message. Okay, and then while sending the message, I will put the message which I am sending, and then the colleague basically this operator over here, it basically represents the current object reference, okay, or the current object which is basically calling this send method. So that's why mediator dot send message comma this. Okay, so that's all from team the abstract base class colleague and teams colleague concrete class. Now let's move on to our teams group mediator, the concrete implementation for my mediator, which is over here. Okay, so very simple. First thing, the Teams group mediator should implement iGroup mediator interface. Okay. Now I have taken example of MS Teams group chat, so that's why Teams group mediator. Now I'm maintaining a list of members who are going to participate into this group chat. Okay, and then I have a method to add a colleague. Okay, whenever I want to add someone into my group chat, I will simply add him or her using this add colleague method. So receives a colleague object. Okay, then I will add that colleague object to my member list collection over here. And apart from that, one important step after adding him to the member list collection, I have to set the mediator object. So how I'm doing? Colleague dot mediator, as I already explained, colleague contains object reference variable for mediator. Okay, it should have a reference to mediator. So colleague dot mediator equal to this. Here, this represents the current mediator object you are using. So in this case, it will be a Teams group mediator object at the runtime. And then the send method. Okay, so public void send, you are sending the message and then you are passing the colleague. So what it does, for each colleague available in the list, as I already said, it's the mediator's responsibility to coordinate and collaborate with all the members in your collection. Okay, or in your context basically, where a set of objects are interacting. In my case, the set of objects are your company employees. Okay, so what it is doing, when it comes to a group chat, whenever you send a message, that will be visible to all other users, right guys? So that's what's happening here. So for each colleague or employee available in the member list, what I'm going to do is, if that employee is not equal to the colleague who is sending, okay, first thing I have to ensure, okay, one check I have put, I think it's not required nowadays, everyone can see the message, even the sender also can see his message. Okay, so what I'm going to do is, if the colleagues in my list, okay, if they are not equal to the current colleague, okay, or the one who is sending the message, okay, first I need to check that the message should not be received by the colleague who is sending it, right guys? So whatever message I am sending, I should not receive it, it should be received by other colleagues. Even if in MS Teams group chat you can see whatever message you sent, it will be visible to you, but internally it will not send it to you. Okay, it's just a representation you will see there. So what I'm doing, in order to achieve that, a simple check I have put, okay, if the colleague is not equal to the sender, basically over here, okay, if the colleague is not equal to the sender, then only you call the c dot receive method on your colleague objects. Okay, otherwise don't do that. Okay, very simple stuff, very easy to understand also. I think it should not be that difficult. Okay, so if the colleague is not equal to the sender, then only you receive. Okay, so except the sender, all the members available in the list will basically receive the message you are sending or the sender is sending. Okay, so that's the Teams group mediator class. And now I will move on to the client application, which basically trigger this. Okay, so let's go to the client application. First thing, you have to create an instance of the mediator object. So in my case, it is Teams group mediator, because I'm using a Teams group chat. So Teams group mediator, I have created its object. Then what you have to do is, you have to create the members, okay, in order to add them to your group chat. So I have created these many number of Teams colleague, basically they are all my company employees, imagine like that. Then what I'm doing, using the mediator, I'm adding all my colleagues with whom I want to do a group chat. So I added all these members to the Teams group mediators dot add colleague. So basically they all will be added to your members collection in your mediator class, that is over here. Okay, program.cs, I will go there again. And once that is done, member one dot send. Okay, so member one sent a message. Okay, he will send a message, hi team, updates from my side. For example, you want to take a quick update of your team, you have not scheduled a meeting, so you will invite them into a group chat, so there people will start giving updates. So there is one member who says, hi team, updates from my side, I did something. Okay, he sent a message. Okay, then another member will start giving his update. So like this the communication will start. Okay, so let me run the program quickly, and I will show you the output, how it looks like. Yeah, so the program ran successfully. So the member one, who is Krish, basically sent a message. That's why I have put a marker here, sent marker. Okay, Krish sent a message, hi team, updates from my side, completed CI/CD for XYZ microservice. See, he is the sender. Okay, he sent the message, that's it. So if you see the other members, whoever there in the group chat, they all will receive the message. So that's why the tag or marker received, they all received the message. And if you see the list, Krish is not there in the list because he is the sender, he should not receive the message. That's why I put a check over here. This check constitutes that condition. Okay, or the requirement, I would say. So that's all about this mediator design pattern. Okay, again one more person called Sampada, she sent a message, she has completed creating a repository in Git. Okay, she sent a message and then all others received the same message over here. Okay, so your mediator is basically is the centralized object, or you would say the coordinator, who is basically coordinating and controlling all the communications happening in your team member or in your MS Teams group chat, I would say. Okay, so let me put a breakpoints and quickly show you how this program will work. I think that will give a clear picture. Well, so the breakpoint has been hit. So first thing, yeah, I created my mediator, Teams group mediator object. Then I will start creating my colleagues. Okay, I created somewhere 7 colleagues. Now, important stuff. I have to add my colleagues into the group chat basically. Okay, to the Teams group chat. So what I'm doing, okay, Teams group mediator using the mediator object, I am calling the add colleague method. So F11, when I do F11, I came to my Teams group mediator and I received a colleague who is Krish. So first thing, this list is empty. I'm adding that colleague to the list. And the second step, which is most important step for that colleague, I'm setting the mediator reference, which is this object, Teams group mediator object reference. So if you see that this represents a Teams group mediator object. Okay. So I assign the mediator. Okay. So that's done. So same stuff we do for all others. Done. Then when member one, any member of this particular group chat sends a message, what will happen? So let me do the F11. So member one dot send, that is Krish is sending a message. So what's happening over here? I received the message. Okay, the message is coming over here. Okay, so I'm putting the name of the person who is sending the message. Here it is Krish. So that's why the marker sent here and then the message what he sent. Okay. Then I'm calling mediator.send. Okay. Provide a keen observation, guys. I am not at all directly making use of any other objects over here or the participating objects or the team members over here. Okay, my mediator is going to do that. So when I do mediator.send, okay, what I'm doing, I'm sending the message, okay, basically, and then also I'm passing the colleague who is sending the message. And who is sending the message? It's Krish. Okay, so these two information is required, so it will go to your mediator. Then yeah, so now it reached the mediator send method. So now here basically it will go through, it will enumerate through the entire list. Okay, 7 members are there. So except one who sent the message, all others will receive that message. And how that's going to happen? First one, this condition didn't met because it's the Krish who is sending the message. Okay, that's why it's not equal to, because these both are same. That's why it is not going to, the Krish is not going to receive the message because both are same. Okay, then I will go inside. This time it will go inside because the colleague is someone else now in the list. Okay, so it's meet. So F11, if you do c dot receive, can you see? Very simple, console dot write line, the person who is receiving the message received a tag and then the message. Okay guys, so that's very trivial example, basically easy to understand this pattern. But when we implement this in real-time applications, I think this will be very complex. It all depends on the need or the requirement for your application or for your business, how you want to implement. Okay, and making use of mediator pattern is also lightweight in nature, guys. Okay, uh, I think that is an added advantage which you are going to get when you use this pattern, because first of all, you are making use of this pattern only for your application specific requirement. So there are third party libraries available in the market, but they are heavyweight in nature. But you, by implementing this kind of pattern specific to your business requirements, basically makes your system lightweight in nature. Okay, so that's why this is a good option to implement, okay, as per the business requirements. So, well, that's all said. I will go to the when to use the mediator pattern. Okay, when there's a need to establish communication between multiple objects to be well defined, but in a cohesive way. Okay, there is a need to establish communication between n number of objects in a well defined way. That's what using a mediator like pattern, but in a cohesive way. Okay, that's what the objects should not be coupled to each other. They should be cohesive in nature. Okay, one object should not be knowing about other object when collaboration happens. Okay, so this mediator should take care of such things. So when there is such requirement, go for mediator pattern. When there is so many relationship exist and a common point of communication is required, when there's a n number of relations exist between these colleague objects, okay, and you want to establish a common point of communication, in such cases mediator is the best choice, guys. Okay, and then to provide a system which involves a lot of entities and complex communication between them, and we need to create such system in a way that it is easy to implement, change, test, and reuse. When you have all these requirements for your system, when you develop it, then definitely you should go for the mediator design pattern. Okay. Thank you for listening, guys. I hope you people understood the crux of mediator design pattern. uh, Thank you for listening and have a nice